Some moments in astronomy feel less like new discoveries and more like the opening of a door that was never supposed to stay closed for this long. That is exactly what happened when the Vera Rubin Observatory captured its first images. At first glance, they look like beautiful photographs of space. But the longer you stare, the stranger they become. Millions of galaxies packed into a single frame. Stellar nurseries glowing with violent beauty. Asteroids slipping through the darkness like quiet intruders. It suddenly becomes clear that this is not just another telescope taking prettier pictures. This is a machine built to watch the sky change over and over again until the universe stops looking like a frozen postcard and starts behaving like what it truly is, a restless, living system. The Rubin telescope was never meant to compete with observatories that stared deeply at one tiny target for hours or days. Its mission is much more radical than that. It was built to look wide, to sweep enormous portions of the sky again and again, and to catch whatever changes. That sounds simple until you understand the scale. This observatory sits high in the Chilean Andes, where the skies are dark, dry, and clay. At its heart is one of the most extraordinary instruments ever built, the largest digital camera in the history of astronomy. With more than 3 billion pixels, it is capable of turning the night sky into a constant stream of high-precision data that changes the entire philosophy of astronomy. For centuries, telescopes have mostly given us snapshots, a still image of a galaxy, a still image of a nebula, a still image of a star field. Rubin is designed for something far more exciting and unsettling: repetition. It will scan the southern sky every few nights, revisiting the same regions again and again until motion, changes in brightness, explosions, and hidden objects begin revealing themselves automatically. This is not just astronomy as photography. This is astronomy as surveillance of the cosmos. That is why the first images felt so overwhelming. They were not simply proof that the telescope works. They were proof that the telescope sees on a scale that makes older expectations feel small. The moment it opened its eyes, it immediately showed that the sky is much fuller, much more active, and much more alive than most people are used to imagining. One of the first released images centered on the Virgo cluster, and what it revealed was staggering. At first it looks like a dense sprinkling of light, but the truth is far more dramatic. Many of those tiny specks are not stars at all. They are entire galaxies, each containing billions of suns spread across tens of millions of light years. In a single frame, Rubin captured a cosmic ocean of structure. Elegant spiral galaxies, giant ellipticals, warped systems, shredded collisions, and faint background galaxies glowing from unimaginable distances. What makes this image so powerful is not only the incredible detail, but the combination of detail and scale. That is Rubin's true strength. Other famous telescopes can show a tiny piece of the universe with extraordinary sharpness. Rubin steps back and reveals the entire environment without sacrificing richness. It allows us to see not just one galaxy, but the architecture of an entire region of the universe at once. It shows how galaxies relate to one another, how gravity stretches them, how collisions tear them into arcs and streams, and how clusters build their own complex histories over cosmic time. That is why astronomers reacted so strongly. This image is not just beautiful, it is profoundly useful. Hidden within that vast sea of galaxies are clues about dark matter, galactic evolution, and the growth of cosmic structure across the universe. The picture looks like a work of art, but to science it is also a map of invisible forces. Rubin's first look did not simply give us a better image of Virgo. It offered a glimpse of how the telescope will redraw our understanding of the large-scale structure of the universe. The second major image was completely different in mood, but no less astonishing. Rubin turned toward the Trifid Nebula and the Lagoon Nebula, two immense regions of gas and dust within our own Milky Way, and revealed them with a depth and breadth that made them seem almost unreal. These are not quiet clouds. They are stellar nurseries where new stars are being born right now. Rubin's image revealed glowing hydrogen gas, blue reflection nebulae, and dark rivers of dust cutting through the light like scars. This image matters because it demonstrates something Rubin does exceptionally well: context. It does not isolate one beautiful pillar of gas and turn it into a portrait. Instead, it captures the entire tangled ecosystem of star formation. You can see how young stars are already reshaping the clouds that created them, carving out cavities, blasting radiation outward, and transforming quiet matter into violent structure. The result is not merely a picture of beauty. It is a picture of creation under pressure. Once again, Rubin changes the emotional scale of what we are seeing. These nebulae are not simply beautiful objects suspended in space. They are active chapters in an ongoing cosmic process. With repeated observations over many years, regions like these will no longer appear static. They will become part of a long-term record, showing how stellar environments evolve. Rubin is not only revealing where stars are born, it is preparing to help us watch those birthplaces change over time. While the galaxies and nebulae captured the public's imagination, one of Rubin's most important early achievements was much quieter: asteroid detection. During its early observations, the observatory picked up moving points of light drifting across its images, small bodies traveling through our own solar system against the fixed background of distant stars. In just a short period of test observations, Rubin identified thousands of asteroids, including previously unknown objects. Some of them were near-Earth asteroids, immediately proving something critical: Rubin's alert system works. This is where the telescope begins to feel almost frightening in its capability. Rubin is not only a deep space observatory, it is also a machine built to detect motion in real time. It compares repeated images, identifies what has moved, what has brightened, what has faded, and what has appeared when nothing existed before.